This is Group H, and welcome to our presentation on the development of a well-being tracker. Our project tackles the UKRI challenge of aging society, as by 2030, which is only 5 years from now, 1/6 of the population worldwide, or about 1.4 billion people, are expected to be 60 years or older. People within this age range commonly have at least one chronic condition, such as arthritis, high blood pressure, diabetes, etc. Additionally, 14% of elderly people have a diagnosed mental health disorder, most commonly depression. Unfortunately, this is also the most common age range for suicide, where 27.2% of people end up taking their own lives. This is caused by many factors, such as housing concerns, the loss of loved ones, and how 33% of older people experience severe loneliness. It is commonly thought that older people may reject the idea of seeking help, as they don't believe doctors or they may be too stubborn to do so. However, studies show the opposite occurring. Many, in fact, would love to seek a doctor or professional. However, they feel unsupported in their journey to do so. This is due to discrimination, which occurs because of age or many other factors, such as race or gender. Additionally, many are afraid of losing their independence and being viewed as a burden to their own families and carers. Our product gives users the ability to seek help on their own terms, independently, without these worries.
So what is the Wellbeing Tracker? The Wellbeing Tracker is a tabletop communications device which allows for a relative or GP to monitor the well-being of an elderly person over an extended period of time. To achieve this, the user is asked a set of questions regarding their well-being which must be answered over a regular period. For example, one question which they may be asked is how they would rate their pain. The user will give a rating between 1 and 5, which will then be recorded on their online profile. Other questions may also be proposed, such as their appetite levels or sleep quality. Once conducted over an extended period of time, the data received by a technician could be used to determine whether a particular medication has been effective, for example, or whether the user shows signs of poor mental health. The Wellbeing Tracker therefore aims to spot certain trends in an individual's well-being so that they are assessed and treated before they become larger issues.
In cases where the user may require immediate assistance, there is an emergency button, which encourages them to call 999 if pressed.
For the server backend, we used Ubuntu Server running on a customized VPS instance where we carried out our work over SSH. We obtained a custom domain for our website accessible on wellbeing-tracker.co.uk, which we certified with HTTPS to make sure the connection is securely encrypted. We installed Apache Tomcat and built our website using Java. In addition to the website, we'd also added an email server for verification and password reset. Furthermore, this email server is also used to host our customer support address, which is support@mail.wellbeingtracker-tracker.co.uk. As for the database that holds the user data, we used MySQL, where the passwords are securely hashed with bcrypt. Both email and the MySQL database are accessible via Apache Tomcat to interface with the website and the Arduino. The same Java interface holds the backend for the Arduino communication, which is also implemented over HTTP. This is all for the server backend.
The website for the customers has been designed with simplicity in mind. There has been a consistent design language applied, and focus has been placed on making the web page clear and easy to navigate. Upon entering the website, the user has an option to log in with a username or password. Otherwise, they can create an account. If they have an existing password but can't remember the credentials, they can click Forgot Password. Once a user has successfully logged in, they are presented with a tidy user dashboard which contains a clear overview of any data collected about their health in the form of a table, as well as multiple buttons below it which provide additional functionality. It was initially attempted to implement a graph to display user data, but due to time constraints, a table was decided as the preferred format. The final layout's advantage is that the data values are displayed very clearly, both for carers as well as the users themselves. Although graphs would have been good for viewing long-term trends, the table allows viewing individual values much more easily. In the future, it can be possible to add this additional functionality. It is possible to have the table emailed to the users as well as paired to their well-being device. Overall, the web page allows the elderly as well as their carers to access all functionality easily.
When setting up the Wellbeing Tracker, the user must access a one-time use code from their online account. Once the code has been received, the user must input the code into the Wellbeing Tracker. If recognised, a cookie will be sent to the server and the Wellbeing Tracker will be paired to the user's online account. When in normal use, the user will be asked a number of questions which will be set by the technician. To improve accessibility, the questions will be read aloud to the user as well as being displayed on screen. Once all questions have been asked, the answers will be stored in a string and sent to the website where it will be stored on the user's profile. For this project, we decided to use an Arduino Uno R4 Wi-Fi as this eliminated the need for an external Wi-Fi module, which also made communication with the server much easier to implement. The Arduino Uno R4 also comes with plenty of data pins which was needed for the number of components we used.
For the enclosure prototyping, we considered using either wood, 3D printed plastic, or a hybrid of both. Ultimately, we decided on 3D printing since it would be easier to revise an existing 3D model compared to making a new prototype out of wood. This leads us to the software used. We started with Tinkercad, but felt limited by its toolkit, prompting us to switch to Autodesk Fusion. There was a learning curve involved due to it being a more advanced software, but it allowed for greater freedom than Tinkercad. The major revision to the design can be seen in this slide. The front panel of the device was angled towards the user to minimize strain on the neck and wrists, and improve the visibility of the LCD.
Let's talk about the hardware part of the device. Me and Jackie is working off this part. There are 6 main components that used for the tracker. The first one is the LCD. The LCD is used to show the questions for the users. For example, how's your sleep quality today? The second one is the Arduino Uno. The Arduino Uno is used to save the programs of the whole device. The third one are the push buttons. There are 6 push buttons for the whole device. They are in color in red, yellow, green, blue, black, and white. The white one is the emergency button for the users. The others is used to answer the questions for the device. The fourth one is the audio model. The model is YX5300. It is used to saving all the audios of the questions, and there's a 32 gig SD card to save all the audios. The fifth one is the amplifier. The amplifier is used to build the speaker circuit, and the model of it is LM3X6. And the last one is the speaker, and the speaker is used to pronounce the questions in audio. Jackie will talk about how we build the circuit of the whole well-being tracker.
To begin the assembly, we first built the breadboard circuit. This included connecting the speaker circuit, which used an LM3X6 amplifier and an MP3 player module. Along with that, we integrated 6 push buttons. These buttons allow for user integration with the system. By combining the speaker circuit and push buttons, we created a functional device circuit prototype. This was the foundation for our final setup. In this setup, we tested the power supply and the on-off switch functionality. We ensured the circuit could power the LED correctly and that the switch operated as expected. This step confirmed that our power setup was stable and ready for integration into the complete device. After that, we combined the component from the previous steps to assemble the full breadboard circuit. This includes the speaker circuit, push button, power supply, and the on-off switch. At this stage, we had a fully functional prototype that could perform all the intended operation of the system. After completing the breadboard prototype, we transitioned the circuit into a Veroboard. This included soldering the same components, including the speaker circuit with the LM3X6 amplifier, MP3 player, 6 push button, and the power supply with rechargeable battery and a switch. The Veroboard provides a more stable and permanent solution compared to the breadboard. So, this is the complete Veroboard circuit. We combined all the parts from the previous slide into one system. It works the same as the breadboard version, but is more permanent. So this is the 3D printed box we made for the project. It is designed to hold the Veroboard circuit securely. The box has cutout for the buttons, speakers, and other components to fit properly. And we place the complete Veroboard circuit into the 3D printed box. So this is the complete box assembly. All the components including the push buttons, LED, rotary encoder, speaker and circuit accurately fitted into the 3D printed enclosure. The design is clean and fully functional.